everyone, welcome back to Brainstorm. This is our Level 2 Algebra walkthrough series. Now in this last video, we're going to go over the second part of quadratics, which involves both the quadratic formula and the nature of roots. So let's get into it. Let's start with the quadratic formula. Now remember, in general, a quadratic can be represented as ax squared plus bx plus c is equal to 0. Now remember that a, b, and c are what we call the coefficients, right? So they're the numbers in front of our x's, or in c's case, in front of no x, so just the constant, right? And so far, what we've been required to do is to factorize our quadratics if we wanted to solve for x, right? And then, yeah, so this gets a little bit tricky when we're given a quadratic like the following. So say we had the quadratic q cubed zy over 2x squared plus abx minus 30n is equal to 0. Well, this is still a quadratic, right? We can pull out a, b, and c values, and this quadratic does have a solution. It's just that we can't really factorize this very easily in order to solve for x. So what am I getting at? Well, what if there was an easier, more general solution for any quadratic? That is there some general formula for any quadratic which will tell us the solutions? And it turns out there is, and it's called the quadratic formula. Now the quadratic formula looks as follows. So it's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now note that a, b, and c represent the coefficients of ax squared plus bx plus c is equal to 0. Right, so this is where a, b, and c come from. And then all we need to do is substitute the values of a, b, and c into this equation up here, and that will solve for x. So why don't we look at an example of that? Let's say, for example, we want to solve 2x squared plus 5x minus 9 is equal to 0. And we want to do this using the quadratic equation. So first of all, we need to pull out what are the values of a, b, and c. So remember that a general quadratic looks like ax squared plus bx plus c is equal to 0. So if we look here, our zeros match up, so that's okay. And what that means is we can just pull a, b, and c directly from the above equation. So if we highlight it here, a corresponds to 2, so a is equal to 2. B is equal to 5, b is equal to 5, and then we're going to pull out whatever's left to be c. So c is equal to negative 9. Now remember, because it's plus c and this is a minus here, we need to make sure we include that minus. So a, b, and c are given to be 2, 5, and negative 9 respectively. So all we're going to do is plug that into the quadratic equation, or the quadratic formula, sorry. So remember, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to substitute this in. So b is 5, so we're going to get negative 5 plus or minus the square root of b squared. So b is 5, so 5 squared minus 4 times a being 2 times c being negative 9. So this is all the square root, and that's all over 2 times a, which is 4. Okay, and then what we can do is we can simplify this down. So this is negative 5 plus or minus the square root of 5 squared, which is 25, minus 4 times 2 times negative 9. So that's going to give me negative 8 multiplied by negative 9, which is positive 72. Right, so 25 plus 72 all over 4. This can still be some more simplified, right? We can go equals negative 5 plus or minus the square root of 25 plus 72. That is going to be 97 all over 4. And so what you can see is that because we have this plus or minus here, this is telling us our quadratic actually has 2 solutions, right? Remember that some quadratics are symmetrical in that sense, right? They have 2 roots, right? And so this tells us that the solutions of this specific quadratic are negative 5 plus the square root of 97 over 4 and negative 5 minus the square root of 97 over 4. Right, cool. Let's look at a bit more of a difficult example. So for example, let's say we wanted to solve abx minus 30n is equal to negative q cubed zy over 2x squared. And naturally, because this is going to be quite hard to factorize, we should use the quadratic formula. So first thing we need to do is get it into ax squared plus bx plus c is equal to 0 form. Now, as you can see from here, we definitely don't have it in that form. So let's rearrange our equation to get everything onto the left-hand side. So this is going to be abx minus 30n plus q cubed zy over 2x squared is equal to 0. And then we want to have this x squared term to be the first one, right? So we're going to get q cubed zy over 2x squared plus abx minus 30n is equal to 0. Right, and if you look closely, this is exactly the same quadratic that we had in the first example, right, as our motivation, right? So we're going to actually use the quadratic formula to solve that. All right, so we've put it into the ax squared plus bx plus c is equal to 0 form. And so what do we do now? Well, we want to find out the values of a, b, and c. So a is equal to, so if we put ax squared plus bx plus c is equal to 0, what are our values of a, b, and c? Well, essentially we just match up the values of x squared, and then whatever's left over is the coefficient, right? Or is the value of a, b, and c. So let's match up all our values here of x first, right? So x squared and x squared, so a in this case is equal to q cubed zy over 2. And for b is going to be equal to, so our x's match up here, so these two values must match up here. So b is actually equal to ab in this case. And then for c, it's just everything else that's left over. So in this case, c is equal to negative 30n. So we've got values of a, b, and c. We can just plug it into the quadratic formula. So we're going to get, remember the standard quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So putting in our values of a, b, and c now. X is equal to negative b, and b is ab, plus and minus the square root, and this is going to be a big one, plus or minus the square root of b squared, so that's ab squared minus 4 multiplied by a being q cubed zy over 2, for a times c, and c is negative 30n, right? And that's all over 2a, right? So 2 multiplied by a being q cubed zy over 2. So this is our solution for x. So if I give myself a bit more space, let's simplify this down. So we're going to get x is equal to negative ab plus or minus the square root of, what are we going to get? We're going to get a squared b squared minus 4 over 2 is going to actually give me, it's going to give me 1/2. Sorry, it's going to give me 2. So we're going to get minus 2q cubed zy multiplied by negative 30n over the 2q cubed zy over 2, which just gives me q cubed zy. Let's continue to simplify. We're going to get negative ab plus or minus the square root of what we've got here, a squared b squared plus, because this is a minus here and a minus here when we do the multiplication, so plus 2 times 30 being 60, and we're going to get to q cubed zy in. So this is all in the square root over q cubed zy, right? So q cubed zy right? Now, can we simplify this any further? The answer is probably not, right? This looks pretty good to me. And so why don't we say this is our final solution, right? So we have two solutions, negative AB plus all of this over q cubed zy, and also negative AB minus all of this over q cubed zy. But let's be more specific, right? How can this be true? This can only be true if our denominator is not 0, right? If it's 0, then we can't multiply by 0. So we have to specify q, z, and y cannot be equal to 0. If they're equal to 0, then we don't, this answer is invalid, right? Next, let's look at the nature of roots. So consider this part of the quadratic formula. So if you recall, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Consider like just the square root part of the quadratic formula, right? So specifically, consider the following three scenarios. So in scenario 1, let's say we had the square root of b squared minus 4ac, and here, b squared minus 4ac, the value of this is greater than 0. In the second scenario, we're going to also have the square root of b squared minus 4ac, but this time, the value of b squared minus 4ac is equal to 0. And in our final scenario, we also have the square root of b squared minus 4ac, but here b squared minus 4ac, the value of that is actually less than 0. Now, what this means is if we look here, we're taking the square root of a positive number, here we're taking the square root of 0, and here we're taking the square root of a negative number, right? So, do we have any issues with any of these cases? Well, can we take the square root of a positive number? Yes, so that's probably okay. Can we take the square root of 0? Yes, that will give me 0, so that's okay. But can I take the square root of a negative number? The answer is no, we can't take the square root of a negative number. And so, this cannot be done, right? At least not in the real number plane. So specifically, b squared minus 4ac is what we call the discriminant. So b squared minus 4ac is called the discriminant. And sometimes we give it the symbol, this triangle symbol, or maybe it's called delta. Now the discriminant is so important for quadratics because it determines what we call the nature of roots, right? Depending on, if the discriminant or this value of b squared minus 4ac is positive, negative, or 0, that's going to actually tell us how many real roots the quadratic has, right? And so what I mean by that, it tells us how many solutions we have for a given quadratic. Right, and so how do we know this? Well, now we're going to have to revisit the quadratic formula. So remember, in the first scenario, we said that b squared minus 4ac was positive. So in this case, we have x is negative b plus or minus the square root of the determinant. So in general, this is what we have. We have x is equal to negative b plus or minus the root of the determinant over 2a. So if the determinant is positive, we're going to have x is equal to negative b plus or minus the square root of some positive number over 2a. And then, can we take the square root of a positive number? We always can. And so therefore, we're always going to have two solutions and the roots will always pass through the x-axis. So what does that mean? We're going to have something that looks like this. So this is my y-axis, this is my x-axis, and we'll always have a quadratic which passes through the x-axis, right? So we're always going to have two solutions. That's the main thing, right? The main thing, doesn't matter which way the quadratic goes, there's always two solutions passing through that x-axis, right? So this is what happens when the discriminant is positive. They always have two solutions, right? Let's write that down. Two solutions. This is really important. Two solutions. Now, what about the second case where the discriminant was 0? So x is equal to negative b plus or minus the square root of 0 over 2a. Now, what's the square root of 0? It's just 0, right? Negative b plus or minus 0 is the same as just negative b, right? And so this is actually equal to, so this is actually scenario 2, I better specify that, scenario 2. This is S1. So our solutions for x is therefore just negative b over 2a. So there's just one solution, negative b over 2a. The root, there's just one solution here, right? Just one answer. And the vertex of the quadratic hits the x-axis. So what do I mean by that? So if we draw out our axes here, when we have the discriminant equaling 0, the vertex of our quadratic is just going to smack the x-axis, right? So it's just going to touch it at one spot, right? One spot. Maybe we just want here, right? So the vertex hits the x-axis, right? And so finally, let's look at scenario 3 where the discriminant's negative, right? So let's say we have x is equal to negative b plus or minus the root of a negative number over 2a. So what's the problem here? Well, remember that we said we can't take the square root of a negative number because we don't look at imaginary numbers. So what we're saying is that there's no real solutions. No real solutions. So the quadratic must therefore sit above the x-axis. So if this is my axis here, this is where the quadratic sits. Somewhere here, it could sit somewhere here, but it never touches our x-axis, right? So we can't say that there's a root. So let's summarize then. So specifically, if b squared minus 4ac is greater than 0, then the quadratic has two roots. Quadratic has two roots or two solutions. So two solutions or roots. If b squared minus 4ac is equal to 0, the quadratic has what we call one repeated root. The quadratic has one repeated root or one repeated solution. One repeated root. And finally, if b squared minus 4ac is less than 0, then the quadratic has no real roots. So the quadratic has no real roots. Okay, and so if we were to just draw one big picture, maybe a few big pictures, so let's do 3 axes just to illustrate this. So the first one, let's do that the discriminant is greater than 0. We'll have a quadratic that looks something like this, right? So it passes through the axes at 2 points. For it equaling 0, it's just going to touch the x-axis and the vertex, right? And if it is less than 0, the discriminant is less than 0, then our quadratic is above the x-axis, right? In fact, let me draw that, right? So it's never touching the x-axis. So what is this, how can we actually use this in our assessment? So for example, let's consider the following question. Example, let's evaluate the discriminant of negative 4x squared is equal to 5x minus 9. And after we do that, let's describe its roots. Let's describe its roots. So first of all, we need to get this into ax squared plus bx plus c equals 0 form. So in order to do that, we'll have negative 4x squared minus 5x plus 9 is equal to 0. So I just move everything to the left-hand side. So my value of a is negative 4. My value of b is negative 5. And my value of c is 9. Now remember, the discriminant is equal to b squared minus 4ac. And this triangle represents the discriminant, right? So this is equal to b squared, so negative 5 squared minus 4 times negative 4 times 9. And this is equal to 25 plus 16 times 9, right? This is equal to 25 plus, I don't even know what 16 times 9 is. Do the calculation. 6 times 9 is 54. 9 plus 5 is 14. So this is equal to 25 plus 144 which is equal to 169. So our value of the discriminant is 169. So what does this tell us? The discriminant is greater than 0. Therefore, so we want to describe the roots. Well, if the discriminant is positive, that means we have 2 real roots. So therefore, 2 real roots or solutions, right? So I didn't even solve the quadratic, but I just already know that there are going to be 2 solutions to this quadratic. Let's do another example. Let's do, for what values of z are the roots of 2x squared minus zx plus 4 equals 0 imaginary? And what that means is that they're not real, right? It's imaginary or not real. So how do we look at doing this? Now, what does it mean to have non-real roots? Well, it must mean that our discriminant is not positive and it's not 0, so our discriminant has to be negative. So the first thing we want to do is say our discriminant is less than 0, or this is the same thing as b squared minus 4ac is less than 0. So now let's plug in for values of b, a, and c. So here we can see a is equal to 2, b is equal to negative z, and c is equal to 4. So let's plug this in. B squared is negative z squared minus 4 times a, which is 2, times c, which is 4 again. This has got to be less than 0. So what do we get? We get z squared minus 32 must be less than 0. And so now we've got a quadratic inequality. So how do we solve for these? Well, if you recall, we just solve it as normal. So we've got, let's just assume it's a normal equation. Z squared minus 32 is equal to 0. So z squared is equal to 32. And therefore z is equal to plus or minus the square root of 32. So we've got 2 solutions, positive root 32 and negative root 32. So, but remember, this is an inequality. So how do we know essentially what the bounds are for the solution? So what we need to do is we need to first graph the solution, right? So what do? So what we need to do is, if we draw up just a graph here. So this is my x and this is my y. Well, we know what the roots of the quadratic are. We know we've got 2 roots, plus and minus root 32. Now root 32 is approximately 5.7. So let's say we put our roots here, right? Just random, right? And also we know our quadratic is positive, right? Because this coefficient of a is definitely positive. So we know that it's going to be like a smiley face, and so we know our quadratic is going to look something like that, right? Not perfect, but estimating our quadratic looks something like this. So, okay, we've said with our inequality that the value here must be less than 0. So where is this true? Where is this value being less than 0 on the axis, right? So this is only true for, how do I explain this? This can only be true for underneath this x-axis, right? Underneath this x-axis. So all the values in here are less than 0, right? Because this is 0 here. So the values up above are positive and the values down below are negative. So this can only be true below the x-axis. And I just realized, because we're talking in terms of z, I should actually call this the z-axis, right? It should be called the z-axis, right? So underneath the values of x are, the entire value here is going to be negative, and above the z-axis, all the values here are going to be positive. And so what does that mean? It means that all the values that we want to include are going to be included in this range, kind of in here, right? And so what does that mean? So this is positive root 32, and this is negative root 32, then my solution for z would be, if z is greater than negative root 32, if z is less than root 32, right? And let's look at one final example. So for example, let's find the values. Find the values of b, where x squared minus b minus 1 is equal to negative b plus 1x has what we call equal roots. Has equal roots. So how do we do this? Well, what does equal roots mean? It means that we're looking for a discriminant which is equal to 0. So first, let's take this quadratic and let's expand it out, right? Or at least write it into ax squared plus bx plus c equals 0 form. So we want it in this form, ax squared plus bx plus c is equal to 0. So first, let's move everything over to one side. So we've got x squared minus b minus 1 plus b plus 1 x is equal to 0. So we've got the x squared terms matching up, but my x term here is all the way on this side. So let's swap it again. So let's do it as x squared plus b plus 1 x minus b minus 1 is equal to 0. So you can think of this as the coefficient of x, right? Or this is our b term. So what this means is a is equal to 1, because we've got 1x squared, and b is equal to b plus 1. And therefore c is equal to whatever else is left, which is this here, which is negative b minus 1. Now, because we want equal roots, we're going to set b squared minus 4ac to equal 0. So b squared minus 4ac is equal to 0. What's the value of b? It's b plus 1 squared minus 4 multiplied by a being 1 multiplied by c being negative b minus 1. This is equal to 0. So let's simplify this. B squared plus 2b plus 1 minus 4 multiplied by negative b minus 1 is equal to 0. So b squared plus 2b plus 1 plus 4b plus 4 is equal to 0. Now b squared plus 6b plus 5 is equal to 0. So now we've got a quadratic here. If we look at the roots 5 and 1, so 5 times 1 is 5 and 5 plus 1 is 6. So we can factorize this quadratic to be b plus 5, b plus 1 is equal to 0. So the solutions of b are negative 5 and negative 1. Okay, and so have we answered our question? Find the values of b where these values have equal roots. Well, yes, we have. When b is negative 5 or b is negative 1, this is satisfied as an equation. Okay? Or specifically, this is satisfied to have equal roots. Sweet, so that's it for our Level 2 Algebra walkthrough series. I hope you have enjoyed. And yeah, thanks for watching.